We're going to be getting started in the next minute or two. It's straight up half past, so we'll give the stragglers a couple minutes. Well, I'm going to start the blue sheets. We can give it a couple minutes.
Yeah, okay. Yeah,
Coming back from I'd give it 5 minutes.
okay. You're right. I. Yeah. First class. Then we go. Let's see.
Do we have Jabber's
So. Good afternoon, everybody. We want to start in 1 minute, 30 seconds. Please find a seat. Welcome to the Dnsop Working Groups, Session 2. I'm Benno Overeiner, Suzanne sitting here, Tim in the room over there. Our scribe is Tim Wattenberg. He's also presenting at the end of the meeting. So who is the backup? Who wants to be the backup scribe for this afternoon? Not everyone. Should I appoint someone? Jabber scribe, yeah.
Only as a backup.
Only as a backup, only when Tim is presenting. Let's find the usual suspect. Thank you, Stuart. Stuart is the backup slide. Paul Hoffman is our minute taker. Next, everybody is familiar with the note well here. The blue sheets, please fill them in, because we have a very large room now, but we want to keep these large rooms. It's very comfortable to hear the echo. The agenda for this afternoon is current working group business, 2 presentations, 2 drafts updates, and some new working group business. All our work, as previously mentioned, is on, of course, data tracker and our GitHub. So if you want to look at that or want to use that, use GitHub. Current working group business, TCP requirements, Dwayne, and the DNS server cookies by Willem, and some 5 new working group business. Some of them have been presented already earlier, but not adopted yet. Good. I think we can get started. I want to ask Dwayne first to kick off. I have here the generic slide for you.
Oh, thanks, Benno. So I'm Dwayne. This is a little update about the DNS over TCP operational requirements draft that myself and John Christoph have been working on. Just a few sort of minor updates since the last time we talked about this draft. We now mention DNS over TLS in the abstract, so to give it a little more prominence there. We added some paragraphs about recent work on avoiding fragmentation, and cite those references now in the the end. The last time this was presented, we got some feedback that we had in the draft that clients and servers should use TCP fast open if available, and we got feedback that that was maybe not a good idea. So that is dropped down to sort of may level suggestion instead of should. There's a couple paragraphs in the document about the KSK rollover, and since that has happened quite a while ago, that has all now been updated to be the past tense instead of present tense. And we added a section on we added some text to the privacy considerations section. It's pretty innocuous, partly to note that DNS over TCP and over UDP itself does not provide any privacy, but if that's what you're after, you can use TLS or DTLS, and then generally updated some of the references. So that's really all that's changed since the last version. It's now at 0.5, and we think it's ready for last call. I was given 15 minutes up here. I think I used maybe 2, so hopefully hopefully there's lots of questions or discussion. If not, that's all I have.
How many people have read the recent version of this document? Any comments? It looks like some of you, it might be good to read it and have any feedback. But yeah, if people are comfortable with it, we can certainly do the last call on the list.
The meat of the document really hasn't changed in quite a while. It's just sort of been the supporting data and anecdotes and stuff that's changed. So. Okay.
Yeah. Okay.
Right.
Thank you. I think we will send an.
I actually have one other question. Have any of the implementers in the room tried to use this document as guidance to the conformance or non-conformance of their own implementations? Okay, I see one.
That would probably be the other document, maybe more. The protocol requirements document is separate, but they are very related. They have a lot of similar things.
What I'm trying to determine is has this document how much has this document been tested against real world activities and assumptions?
So this is Paul Hoffman. I got the feeling that, and correct me if I'm wrong, Dwayne, that you really stayed away from requirements and such in this document, that it really was, if you are doing this, don't forget about these other things. In fact, don't wait until you've implemented to think about these other things. Think about them ahead of time. So that might be, I mean, Suzanne, another sort of way to ask it is, has this been useful to anybody reading through as they were doing their implementation to go, oh, whoops, thank you. I mean, to me, thank you would be the best parts of this. So
that's actually a better form question. Thanks.
Andre, I see. Let me clarify. We just put a completely new networking stack in bind, and we'll be definitely using this document as a base of tuning it into like well-behaved DNS server again.
Thanks.
Okay, that's exactly what I was looking for. Thank you very much.
Brian Dixon, GoDaddy. We haven't, but we will. I mean, we're going to look over it and check it against our implementations. We expect it to be useful. Thank you.
Okay.
So, sorry, one question. Brian, thank you for that offer. Do you have an idea of a timeline? Can you do that in
sometime between now and the end of the year, probably. Okay. Probably sooner than that.
Yeah. Okay. Because thank you for the practical. When do we go for the working group last call?
Yeah.
We can wait for you if it's before the end of the year.
Yeah.
Is that,
Feel free to ping me if I
okay
haven't
with you,
responded.
Sure. Yeah.
And again, it's for authoritative DNS that we have our own implementation on.
Thank you.
Relaying for Peter Spacek from Jabber. We plan to extend TCP TLS testing on not resolver, so we will have some feedback next year.
That's pretty vague.
Yeah, we won't wait that long, but maybe we needed this then. Okay. But I think everything between now and in 4 to 6 weeks, before the end of the year, I think is acceptable, but then we have to make progress. Yeah.
Okay, that sounds like we can go ahead and kick off the working group last call.
Thank you.
Thank you.
Yes, so this is about the draft that gives the recipe that for DNS server cookies that caters for all the different vendors. So all UDP services that reply with a bigger response than the request, like is possible with DNS, they are susceptible to be misused for amplification, denial of service attacks. And this is the kind of attack
I think
in
you need to
which
get a little bit closer to the microphone.
closer to the microphone.
There you go.
Yeah, that's better. So it's the DNS cookies are to protect against reflective amplification attacks. This is the attack where the attacker spoofs the IP address of the victim and sends a lot of small DNS queries, which will be result in a large answer with which the victim will be flooded. And DNS cookies are a DNS native mechanism to deal with these kind of attacks. Note that TCP, DNS over TCP would also be a solution because it has a handshake, so spoofing is not possible. But TCP requires quite a lot of state at the server, and DNS cookies are very lightweight. They do not require a lot of state at the server, actually just a single secret for all the relationships with all the clients the server has. So it is like a handshake though. So a client, this is how it works. Client creates a client cookie, which is basically a nonce. The server generates the server cookie based on the client cookie and the client IP address, and then returns the server cookie alongside the client cookie in the DNS response. And in subsequent requests from the client, the server will recognize, yes, I'm the only one that could have created this server cookie. So I've seen this client before. I will provide larger answers for it if it wants to. I will not truncate these answers. And also, this client does not need to be response rate limited anymore. So what was the problem? RFC 7873, the DNS cookies RFC, did a great job at defining this mechanism, except that it was sort of liberal in how the server cookies would be created. So the cookies cooked by or baked by one vendor were not appetized or well received by another vendor. And this draft is to deal with that and create a recipe that all the vendors will use, so they will all recognize each other's cookies. We started to do implementation for all the well-known open source DNS vendor implementations at the hackathon in Prague at the IETF 104. And that was a big success. We had working interoperable server cookies for those implementations. So we thought, okay, we're almost done. We just have to do the client cookie and then interoperable test each other's implementations, the resolvers to the authoritatives, etc. And then we're done. This can go to last call and we're finished. Except that didn't happen. So we focused on the client cookies in Montreal and we discovered that there's a problem. And to explain to you why there's a problem, I've given here the recipe for client cookie that we no longer use. It's no longer in the current draft, but it was based on the client IP address, the server IP address, and a secret. And we need to include the server IP address for minimal authentication, right? It needs to have a different cookie for its different relationships. And client IP address needed to be in there for privacy. If a client would move from one network to another, its IP address would change. And if it would have kept sending the same cookie, it would have been trackable by the DNS server, so to say, and other observers. So also IPv6 privacy extensions are a thing that, so the cookie should be based on the client IP address for privacy reasons to not be trackable. So here's a piece of pseudo C code that does that exactly that mechanism. And this is replacing basically send to. And so everything up to the path to send to at the bottom of the function is what we need to do for client cookies. So you might ask, why is this not simply a if we have a server cookie for this server, send it, and otherwise create a new client cookie, because that's obviously the more heavy operation here. That's because we need to know the client IP address to create a client cookie. And if we send it an old cookie, then it might be based on the old client IP address, right? So how this works is first it uses get sock name to get the client IP address of the cookie, creates a new client cookie. Is the cookie the same as what we had stored for the server already, then we're fine if it also has a server cookie. If not, then we set all the cookies so new ones are calculated. So by the way, besides not dealing with all the error codes, this piece of pseudocode has another major flaw. I think some of you might know what that is. That are familiar with socket programming. So you cannot get the client IP address from a unconnected UDP socket, right? So get sock name doesn't actually give you the client IP address. So there's a trick to do this. You create a trial socket, then connect it, and then sort of fake connect it to the server and then get the IP address and then close the socket. So when we discovered that we had to do this, us implementers thought, well, this is the straw that breaks the camel's back. Right. So even so, the draft was adopted by the working group. And we adopted the text that said, well, if privacy is a concern, then just don't use cookies. And then on the list, people, Philip Homburg mainly, said, well, that's a real pity, and I think there might be a way to deal with this. And so there was a lot of discussion, both on the list and off the list, because we don't want to bother the working group with all the technical details. But this is where we've ended up, and we think this actually works, preserves privacy, and also has a short path towards sending out client cookies. And so it's completely leaving out both the server IP address and client IP address of the client cookie generation. It's just a 64-bit nonce. It's if a client sees a new server, it creates a random cookie for it. And then only if the server returns a server cookie, it will store this client cookie for that server alongside the server cookie and also its client IP address. Then the next time the client will connect to the server, it will bind, and it has this server cookie, or it connects to a server which has a server cookie. It will bind to the IP address, which will, cause failure if IP address changed, and so it can then create a new client cookie. So this was tested at a hackathon, and it sort of works.
Okay, Paul Wouters. So I'm a little confused. So you don't want to put the client IP address through a hash function for privacy reasons, but you still keep the client IP address in memory with the cookies. So what privacy have you gained? That's not clear to me.
The privacy is that you would not send out the same client cookie whilst your IP address has changed. So cookies can be used to track a client unless it's different every time the client IP address changes as well.
But that cookie would be invalid, right? Because it would be rejected
Yes,
anyway by the
that's
server.
fine. Invalid cookie is fine. It's just the client cookie. So a new handshake will be set up with the server.
Okay, we'll take it offline.
Let's Hardiker ISI. So I agree with Paul that I understand that if the cookie never changed, that would be a problem. But why can't the client just change its secret all the time? And
yes, so indeed, so that cannot be done because that would mean that if a server does not support the cookies or pretends not to support cookies, the same cookie would be sent to that same server even though the client IP address had changed.
I think what I'm saying is that if a client wants to manage its privacy, it can dictate how often it creates a new cookie with a new secret that it randomly generates. It could do it on a regular basis, or it could keep it long-lived.
Yes. Yes, so we also do not want to, we want to introduce as little operations as possible on the path to send to, right? So what we now propose in the draft, it's actually not on this slide, is that if a server does not support cookies or seems not to support cookies, then the client should just remember that and not try to send a client cookie to that server for a certain period before it creates a new client cookie, which is key. And therefore, just a secret and server IP is not enough to that non-cookie supporting server. So it took us a little while to get this right, but yes, no, well.
Hi, Willem. Jim Reeds. Separate comments. In the draft, it talks about not having to change the cookie often. How often is often?
So if your client IP address does not change, then you do not need to change the client cookie often. Indeed.
Yeah, but
so that's a year. But you know,
how often is often? Is it every 5 transactions? Is it every 5 minutes? Is it every 5 days? I think it may be better to have some guidance. Maybe one of the trade-offs could be about how often is, but a document just says often without giving any kind of indicative values there doesn't seem quite. I think it needs a little bit more clarification.
Jim, there's 1 year in the draft set?
Yeah, there used to be 1 year, but maybe I left it out in the last draft. I don't remember precisely.
I think it's still there.
It's still there?
It's still
Okay.
there. I think it's still there and says it doesn't have to be changed often, at least 1 year or something. But the thing is that use your best cryptographic knowledge, and if the secret is not compromised, you don't have to change it at all, because unless the cryptographic function is compromised, then why change it? It just complicates things.
And also, you should not do any effort to remember the client cookie, right? So it should not live, or it should not be kept between server restarts or so.
Yeah,
It can
I
just
think
be
some
just-
implementation guideline might be helpful for people. But leaving it as often just seems to me as a little bit too vague, a little bit too fuzzy.
Okay.
Paul Hoffman, seeing that there's been a couple of questions, I think your decision to have the discussion happen offline for this change might not have been that great. So can you bring things back to the list for this, just so that the questions can get resolved, not just by reading the document, but also by seeing the logic? And also to Jim, it does, I just did a quick search on there, is right, it does say 1 year.
Yeah.
So we've done this because the document, besides a modified constructing the client cookie section, also now has a new security and privacy considerations section elaborating on, the new method and why it needs, what the precise reasons are for this method.
So it sounds like where we're at is more implementation experience and more discussion on the working group list, and maybe next call before Vancouver.
So indeed, so the new draft has been posted to the list on Monday, though. So I invite you all to review it carefully, especially the security and privacy considerations. And And then once that's settled, then we can do a implementation or get implementation experience with the software vendors and get it over with, I suppose.
Excellent. Thank you. Any other comments, questions? Or, oh, good. That means people are going to go forth and code and see how that works. Thank you.
Hi. So this is our DBD draft we mentioned last time. The mechanism in 03, which we've updated recently, is pretty much the same. There's a lot of editorial changes, some clarifications based on discussion last time. Implemented it more. There was a bit of code before. There's a bit more now. And deployed it on a small set of domains of mine. There's code there. It's a bunch of Python code and some bash scripts to create zone file fragments, and a bash script. It's kind of a wrapper around dig just to make it look a little bit less horrible. And the signature verification and creation stuff, which is the most complicated bit of this, is included in that implementation. And kind of works. Looks like that. It's lovely. Yeah. I think that kind of has pretty much all the features of the draft nearly. There's another domain that uses 25519 SIG as well. And that's kind of it. Our goal, I guess, is to progress a flavor of this if somebody would want it, and take questions and comments. So I think it's at the point where it's ready to either kill, adopt, pause, whatever. So I have a couple more slides explaining it if somebody needs, but we did those last time.
All right. You want to go to the microphone, Warren?
Warren Kamari, Google, no hats. Can you remind me again what exactly the use case is? I mean, I've read it a few times, but can I do stuff like, can you publish a record saying that your a related domain is apple.com? Like, it feels as though unless you have them pointing in both directions, the semantics gets a little odd.
The semantics could get a little odd for some use cases like that, yes.
Okay.
But you can, both sides could do it. If you're going to say unrelated, that's kind of not going to be bidirectional. There are some cases where if you use the signature mechanism, it doesn't need to be bidirectional because the signature can kind of get you that. Whether that is something, it would make sense in something like a membership organization if you wanted to do it that way.
I guess the unrelated use case seems great to me. The other, I just don't fully understand how I would use it or when I would trust it. But the unrelated is really useful. More than happy just for that. Yeah,
again, I mean, the idea here is to do a kind of really minimal semantic. And then if you have an additional semantic that does require bidimensional, then there's a tagging thing there. Hey.
Relaying for Peter Spacek. Out of curiosity, did someone outside Dnsop indicate interest in this mechanism besides theoretical use cases? I'm looking for practical use cases, not just the theory described in the draft.
I didn't quite catch that.
So Peter is asking for real-world use cases which are not just theoretical, and asks if somebody explained interest in this.
Sure, but I mean that's a great question. That's a question I have. Alex from Comcast has what he thinks are real use cases. Personally, I don't really, other than for research, if I want to do zone surveys and so on. But Warren
Kamari, just a quick clarification. I support the draft. I was just more confused about the thing. It wasn't meant to be taken as a...
Sorry for confusing you. Daniel.
So Daniel Migo Erickson. The question I had is, do you have it evaluate how it's going to impact all the responses, the size of the responses on the real traffic, or?
But if you add signatures, you get bigger responses, obviously. But other than that, they're pretty tiny.
Okay.
John, you've been converted and now you love it.
Hi, it's John Levine with two separate comments.
Sure.
One, just for the record, I'm still not thrilled with the justification for inventing a mutant form of DNSSEC signing here rather than using DNSSEC. Yeah, because I find the arguments unpersuasive. My more serious concern is that I don't see how this is useful without something along the lines of the Mozilla PSL to say like all the stuff under these two names are parallel. And given that we've kind of given up on standardizing anything on the PSL, I'm thinking that I would put this on the shelf until we until we come back and see if we can take another whack at the debound problem.
Okay, so this is very much on my part an attempt to try and see, is there a small subset that's smaller than the PSL debound problem that is worth doing? And the answer might be yes or might be no.
This is sort of the same part of the problem that Andrew Sopa proposal attacked. I mean, he did it in a different way, but it's this. I mean, you can imagine, just barely, sort of papering the trees with parallel things, which would be, I could write a Python script to do that, but it would make things look pretty ugly. But I guess I would like better worked out examples that don't say, and of course, somehow you know that the subnames are the same, because at this point you don't.
Okay. Tim
Wasinski speaking for myself. We actually do have a real legitimate use case with my employer trying to solve this problem across organizations, across domains, across sort of customer organizations sort of thing. So this is like step one, and we have a step two idea in our head, but we'd like to see something like this sort of start to happen. So answer that question.
Thanks. So looks like John again.
Just to clarify, if we could somehow deal with the parallel with the subtree boundary problems, I totally agree that saying two subtrees belong to the same people is a useful statement to make. I'm just not sure that this is the right way to say it.
Okay. So I guess it's kind of up to you wise chairs to figure out what you want to do.
Yeah, I was just thinking about that. Thank you for summarizing that. No, but I do hear mixed opinions here in the room. You want to? So we, yeah, indeed. So, but that indeed. How many people did read the document? Okay, quite a few. Excellent. And I like, well, as you stated at the start of your presentation, what do we do with the document? Do we continue? Do we kill it or something else?
Yep.
So I want to, also from the room, a little bit mixed impression, pro or con. I want to take it to the mailing list.
Sure.
And I think some people do see the use case. Please also on the mailing list reiterate that, because that might convince the other people that it is useful to pursue this work in the working group. Paul.
Paul Hoffman. So we had a vocabulary problem in ABCD yesterday, which has just come up here, which is the word this. Like yesterday in ABCD, or 2 days ago in ABCD, there was the how many people want to work on this? And a lot of people raised their hand. And then when there was a discussion, it was very clear that they had a different this. This is a great example of a different of this between this document and John Levine's debound. I'll be very blithe here and say what is proposed in this document are a couple of things which Stephen has said are extractable, and he might be happy with just one of them. Debound, John's debound is somewhat boiling the ocean, but in a way where everyone would then be happy if we could get there. So I'm a little bit hesitant if you go to the list and say, do we want to do this? Because I believe some people would agree with what Stephen just said, which is even a little bit, starting with just a little bit of this would be good, and there's a practical reason for this one little thing. Other people, of course, are going to be happy to boil the ocean. This is Dnsop. But I think we need to, the question needs to be much more narrow. And you might even say, how many people would support adopting this document if it was just Section 3, just, something like that.
So I can make a suggestion. I think it's a valid point to try and distinguish, what we've put in this document versus the bigger problem. So maybe the question would be, do people want to adopt this document or bits of it? And try and distinguish that from the bigger question, perhaps. Yeah. But okay, so take it to the list, I guess.
Yep.
Thank you.
We take it to the list. Thank you.
Yeah. I think the chairs need to sort of consult on what's the most useful way to form the question. So we will take it to the list. Thanks, Stephen.
Danielle. Yeah.
Not as tall as Stephen, so take the mic. So DNSSEC resolvers, operator recommendations. So it's a draft so a little bit of history. We already presented some previous version of that draft, but we just handled it the bad way. So I think now we're achieving the initial goal, which is to provide some recommendations for the operator. And the main thing is to encourage them to deploy DNSSEC. Okay. Oh, okay. So the motivations. So a little recap. How much time do I have? 20 minutes. Okay. So motivation. The trust in DNS validation relies on the signature, and the trust, which is the owner of the private key associated to the DNS key, is the legitimate owner of the signed R. So you have a trust anchor, and then you have a chain of trust where multiple DNS keys are validating each other's. And each of those keys can be okay. Each of those keys can rotate over time. So the real flat model for DNSSEC resolver operator is then to consider what should I do and what happens if there is a malicious DNS key that is being introduced. So the operational recommendations we have are basically encouraging those DRO to enable DNSSEC validations and to provide them sufficient trust into the DNSSEC validations. So we have some categories, which is we address the provisioning, the monitoring, and the management. And I think maybe an important part of that document is to clarify what is actually the responsibility of a resolver when DNSSEC is being enabled. So to demystify that is, well, when you ask, can you enable DNSSEC validation? Well, if something goes wrong on the internet, I'm going to be held responsible for that. And well, we'd like to go against this myth and say, no, it's not you. So even though we have 20 minutes, I don't think I'm going to explain it here, what is a validator. But the document has a clear, has a recap of what's the validation process, what are the different modules that have been involved into that. So you have the time, the cryptographic libraries, you have the DNS cache, and then, well, the DNSSEC validation engines with DNSSEC message that are also being used to manage the trust anchors. So, what are these recommendations intended to do? So we first like to minimize how those operators do interact with the validations. The main principle is to let DNSSEC go on. We don't want to tweak the protocol, nor that they require some expert in DNSSEC. So the expectation is that they just be sufficiently confident that enabling should be sufficient. We also stress on the importance of having automated operations to minimize the operational errors, and to focus on preventing the configurations error, as well as provide some early detection mechanisms. So the categories we defined are into three. You have recommendations for startup. So when you start up a resolver, you have runtime recommendations. So what should be done on a running resolver, and some more specific actions that are classified as on demand. So in some cases, we expect that those operators may want to check some specific things, so that's part of the on-demand. So time, well, time is important for the signature check. So basically what we ask first is that a validator should not be started before the time being synced. And if there is an error, it should not be started. And over time, so the runtime recommendations is that you regularly check the time, and eventually you can ask for the time of your platform that are running the resolvers. So, the thing with time is just to make the difference between the categories of the recommendations. So startup, runtime, and on-demand. Then we have a list of recommendations that are based on that are targeting the DNS key record. So I'm going to start with the TA, trust anchor. So we have positive trust anchors, and we have negative trust anchors, and all of those belong to a trust anchor store. Yeah. So when we're talking about management of those trust anchors, well, you should consider that they are being configured. It's a configuration thing. So, well, the DRO should be able to have their own configuration, and to ensure that the DNSSEC resolver, when it's started, is start with the appropriate TA or NTA. And
when we are thinking about TA, it's the TA with the right value. I mean, the up-to-date value. Then those TA, I mean, they are not. They must not be hard-coded somewhere. So they should be able to be updated. So within the resolver at that point. So, and it should be also possible to check and to report what is the TA being used. So what are the TA considered by this DNSSEC resolver? So because TA get updated over time, it's quite important to prevent that the DNSSEC resolver starts with an old TA, and so the configuration of the TA is really has to see as a two-step process. You define which entry point you're going to trust, and the other that corresponds to the trust model, and then what is the actual value of that TA? It does not belong to the trust model, but it's more related to the configurations. So there is a provisional step at that point, and we would like to split those two because the trust model is likely not to evolve so much, but those value associated to the TA are likely to evolve over time. So the theoretical process for configuration the TA is that the DRO defines the domain name it trusts. So it's really the entry point. And that corresponds to the trust model, and it's expected not to change over time, or I mean during a long time. And then once you know which entry point, so if it's a root zone, or if it's some other TLDs or whatever, once you know that, you should have a third-party mechanisms that is going to retrieve the appropriate value for each TA. And once you have your TA, you can and TA, you can generate the configuration file. So, well, I'm saying possibly young, but it's to have a single process. And then once that's done, the resolver can be configured and started. But they should not be started without having the step A to be defined. So with that model, only the DRO, I mean, only the trust model is defined by the DRO, and everything is being automated. And the TA are always being provisioned with the latest values. So the main advantage is that by doing so, when you reboot a machine, when you reboot your resolver, you don't have to check that the TA have been recorded into the file system that is only write-only, that is only read-only, for example. So once you reboot, you're always, you always have the latest and the appropriate values for the TA. Now, the other thing is, so did I miss the slide? Okay, so one recommendation is that when you start up, you should rely on a bootstrapping mechanisms to retrieve the TA. And well, the DNSSEC resolver must validate the TA before starting the DNS resolver. And of course, if you have a failure, it should not start. So now that we have multiple steps to configure those TA, we want them to be deployable and realistic. So a possible way to, and I think a simple way to implement those recommendations is actually you have a DNSSEC resolver that is already configured with the right trust anchor, and so it's likely to fit the trust model for 99% of the ISPs. So in which case, I mean, the trust model is agreed by the provider of the DNS, the resolver software, and the value is checked by that software provider. And so the only thing an ISP, an operator has to do is download the up-to-date code and start the code, and that code need to check that it's the right value with the appropriate mechanisms, but that's fine. If you want a trust model that is more complex, then yeah, you may have you may need the infrastructure to have the different steps. But what I'd like to emphasize is that even though we decompose those steps, the deployment for the vast majority of operators should be quite simple.
So, Leif Johansson. So, is it meaningful to expose that choice of how you establish root or bootstrap trust to the outside world? I mean, the fact that you're essentially relying on the software signature key or of the distribution, right? Whatever software distribution you're using. That's essentially what you're saying, right?
Yeah. So the question is whether we should
whether that choice, right? You're choosing, right? If what you're saying is probably true, right? 99% of the world will just sort of, trust the Debian signing key, right? And that signature, right, is how you anchor trust in the initial configuration, right? So, but others may choose to do other things to bootstrap trust. So, is that choice something you want to expose if you're talking about sort of making trust like auditable from the outside?
So the way I understand is that the DRO should mention which ways he's gonna bootstrap.
Right, exactly. If I'm looking at the DRO, right,
yeah,
and I'm trying to figure out whether I want to trust that resolver, should this be information that I can get at, right?
Okay, so
should there be a field somewhere in a public like file or something that says here's how I establish trust when I boot my resolver. I do this, right?
Okay, so that I don't know. I don't think it's in the draft. We haven't thought of it, but it looks to me more a legal perspective than.
Right. I mean, I'm just saying this because trust management is all turtles all the way down, fundamentally, right? And what you just said essentially amounts to saying that we trust software signing keys, right?
Okay. Yeah.
So now you've moved sort of trust in the root zone signing key into trust in the software signing key.
Okay. Right. Yeah. So,
Daniel, as a point of order,
yeah,
you have 7 to 10 minutes left, and I just looked in several more slides. So do you want to finish going through the slides and then go to discussion?
Okay, right.
Or how do you want to do that?
Okay. Well, I think we can stop whenever time is off. So I'm fine answering the question on the. So
just wanted to make sure we didn't run off the end.
Okay. No problem. Otherwise, I mean, I'm fine if you only see half of the presentation.
Okay.
So yeah, it's actually a good point, and I think it's under-specified in the current version, and I think we should add text on that. Yeah. So thank you for the comment. Yeah. So for the update, what we'd like to emphasize is that the update should not be manually provided by the DRO, so it should be mostly transparent for him, and. And another thing is that we would like that the resolver have this signaling trust anchor knowledge being enabled, so that I mean a DRO can request its resolver to check which is the TA being used. So that's one recommendation, to keep an eye on it and not The reason we recommend this mechanism is that so the operator does not open the configuration interface. Runtime, well, it should regularly maybe, so it's a should. It's not necessary, but it's just recommended that it checks the health of the TA. And so one important thing is that it's only the cache TA. We don't have to check, well, did he when the update has been performed, is the update, the new key actually stored into the configuration file on the system? So in case of reboot and so on, no, because we have a first way to provision the resolver. So, and on-demand recommendation is that, well, you should have the tool to say what are the keys being used by my resolvers. So the way I foresee that is that when a key rollover fails, the DRO should not try to repair it. It should reboot the resolver. That's basically the line in our recommendation. It's a bug. It's not in the DRO is not expected to address those concerns. It's considered as a bug, and so it should restart the resolver. So we exposed some specific requirements for the TA. Now we go through the ZSK KSK. So the runtime recommendation is that it limit the TTL of the record under that zone to the one of the ZSK KSK to avoid incurrency between the cache Rs and the ZSK KSK. So some sort of generic recommendations to all kind of DNSSEC key, so TA, ZSK, KSK, and TA. So a running recommendation is to have to automate the reporting. So that's the one where we recommend that the resolution reports to the authoritative server which key is being used, so that this authoritative server that is sort of responsible of the right validation for its domain is likely the first one to move and to maybe contact the resolver ECs with, for example, a non-updated key. So for negative trust anchor, most of the recommendation is to make that feasible and to follow the recommendations in another document. And so runtime, well, we should monitor the failed signature associated to each key. It's a should, so it's a nice thing to have, but it's not necessary. And maybe if you want to be able to to find out if ever something goes wrong, why it goes wrong, then you may collect also some status of the key or other informations, but that's really optional. You should be able, if something goes wrong, an emergency cache rollover, KSK rollover, to flush the cache. So initially it would be nice to be able to only flush the Rs associated to the KSK. Suppose you have a corrupted KSK and you want to only flush the Rs that has been validated by that KSK, but flushing the full cache is also something possible. Crypto deprecation. So we want to be able to move the crypto and be able to update the crypto and not having a software that carries all the legacy crypto. So we would like that DROs are confident to say, yeah, this type of crypto is never used, so I can decently remove the crypto library as associated to that signature scheme or whatever. So that's a recommendation. We recommend to check what is actually being used in the software. Invalid recommendation is when something is invalid, it would be good to have a system to be able to report that to the maybe to the authoritative part of that. It's basically to help to take the right actions if something goes wrong, or it's anyway an interesting information for to share. So these are basically the recommendations. The real hope is, so we would like to get feedbacks, and again, the real goal is that operators could easily enable and feel confident to enable DNSSEC.
So yeah, we do have a few minutes, so go ahead.
Okay. So Chris Box, BT, I just wanted to say thank you for creating this document. because, well, thank you to you and all the contributors to it, because we're at the point of just working on enabling DNSSEC validation. So, yeah, it's really useful to have this available. So looking at the history, it looks like it's been in draft status for the past 5 years. So it's an ongoing thing. So is from this, are you intending to publish it, or is this something that you expect will continue to need ongoing additions?
I think we're now, I guess we're pretty mature now. The reason it has been for a long time in the draft state is basically we had issues to position correctly. So we were, I mean, the previous versions are mostly having some mechanisms, mandatory mechanism for the DNS resolvers, which is not the right way to, so we figure out how to do that. But I think now we have the right path to, and I'd like that document to be adopted. That's
okay. Thank you.
Hi, Yoshiro Yonea from JPRS. I support this document, and I have one comment regarding to NTA operations. The importance of NTA operations is to have a deep contact with the customer support center, because users' claim comes to the customer support center, so that the operator have to have channel with them to know something strange happened, and also customer support have to know when the DRO enables the NTA for a certain domain name, then customer support center would have claim from the users this domain name is not validated. So such kind of the interaction between the operation in the server and the customer side are very important, so that my comment is to write such kind of relation with the
okay.
support center.
So, but I think what you're asking is already in the NTA document. So maybe we should emphasize on that in the current draft. That we can do, but I think the NTA document is pretty clear that there is another channel, and this has to be advertised through websites or this kind of thing. But yeah, I'm taking that comment. Okay.
So before you step down, I don't think we did this before, although my mind is going. Who here has read this document? Who is more likely to read it having seen the presentation today? Good, that looks like a lot of reviewers. So I think it'd be good for the folks that are interested in doing this, I admit this sounds useful to me. If you are interested in the topic, please go ahead and read the document, provide feedback to the authors, and we'll look at the level of interest and progress and consider adopting it.
Okay, thank you.
Next up, Fujiwara-san.
Hello, I'm Kazunori Fujiwara, and today I will talk about draft Fujiwara Dnsop avoid fragmentation 01, avoid fragmentation 01, avoid fragmentation in DNS again. RC 8085 UDP usage guidelines, BCP 145, published in March 2017. Section 3.3 message side guidelines specifies that an application shouldn't send UDP datagrams that result in IP packets that exceed the maximum transmission unit MTU along the path to the destination. And an application should either use the pass MTU information provided by the IP layer or implement pass MT discovery PMTD itself to determine whether the path to a destination will support its desired message size without fragmentation. And previous BCP 145 RC 5405 November 2008 unicast message size and unicast UDP usage guidelines for application designers already have same text. Then avoid fragmentation in DNS, avoid fragmentation in UDP is effective after November 2008. And I checked fragmentation in DNS RFCs. And DNS RFCs discuss issues of fragmentation. And note that pass MTU with or without fragmentation may be smaller than this. And RC 3226 DNSSEC and IP version 6 are where server resolver message size requirements. All DNSSEC and IP version 6 compliant entities must be able to handle fragmented IP version 4 and IP version 6 UDP packets, and must support EDNSL and advertise message size of at least 1220 octets, but should advertise message size of 4000. And RFC 4035 DNSSEC says that must support a message size of at least 1220 octets and should support message size of 4000 octets and must handle fragmented UDP packets correctly. As a result, without cache poisoning attacks using IP fragmentation, we need to avoid fragmentation in DNS. And we need to consider maximum UDP message size. RC 8085 use the pass MTU information provided by the IP layer or implement pass MTU discovery itself. Then retrieve pass MTU value to each destination or use interface MTU value or minimal MTU 1280 in IP version 6 and 576 in IP version 4 minus IP header size plus UDP header size. And then possible magic number maximum DNS UDP size may be larger than or equal to 1220. RC 4035 DNSSEC defines at least 1220 octets. And most of internet support MTU, 1500 MTU, 1500 octets MTU, and minus some headers. Then maximum DNS UDP payload size may be 1400. And DNS Flag Day 2020 people proposed 1232. And the draft proposes recommendations. UDP requesters and responders should send DNS responses with IP version 6 don't flag options. Upon a timeout, UDP requesters may retry using IP version, using TCP or UDP transport. per local policy. And requesters should compose UDP responses which result in IP packets that do not exceed the pass MTU to the requester. The maximum, the estimated maximum DNS UDP payload size should be the actual or the default maximum DNS UDP payload size. And the value may be, the value is equal to or larger than 1220 and smaller than or equal to 1400. And maybe 1232. And zone operator should consider small response size configuration. And fragmented DNS UDP message size, fragmented DNS UDP messages may be dropped before IP assembly to avoid cache poison attacks using IP fragmentation. And how to retrieve pass MTU value to a destination is written in manual page. Please see get socopt manual on Linux. And I don't know how to get the value on BSD. And this slide shows changes from 00 to 01. New co-author Paul Bixby and 01 refers RFC 8085 UDP usage guidelines and updated text using EDN0 terminology. For example, sender is changed to requester and receiver is responder. And added text about estimated maximum DNS UDP payload size. And added zone operator should consider small size configuration. And added how to retrieve pass MTU value. Is the draft useful? And please consider adapting.
Hi, Andre at IC. I'm sorry, but there's a draft in int area that tackles exactly the same topic from its named UDP fragmentation considered fragile, or IP fragmentation considered fragile by Bonica, Baker, Jeff here, and other two people. I don't remember. Sorry. And I don't think this working group should adopt this work until that work is finished. And I would suggest you to, because none of the things you talk about is DNS specific. It's UDP specific. So I don't think we should adopt this work until that work in the end area is finished. I think that you should go compare the two drafts and provide a useful feedback to them and finish there. And only then we might have a draft in the DNS op that will say, look there, do that, with the DNS specific things, because none of this is DNS specific. It's IP and UDP specific, and it should be tackled at that level. Thanks.
Warren Kamari, Google. Following up from that, I'm assuming that you're meaning IP int area fragile. That's actually with the RFC editor, so it passed ISG eval. Eventually. Yeah. There was some controversy, let's say.
and the draft doesn't say avoid fragmentation in UDP.
I'm John Levine. I think we actually do have DNS-specific stuff that is useful to say. And in particular, the traffic from a resolver to an authoritative server, like you can't tell what network it's going to go over. So so all this advice about being conservative about what sort of packet size you use is relevant. On the other hand, I have a resolver on a network that I completely control. And there's lots of resolvers like on ISP networks where they know a lot about the topology of the network below it. So I think we should adopt it. I mean, I have no opinion about, I think we should make sure we don't contradict anything that the transport people say. But I think there are some useful things to be said, like if you know all your clients are on the same network and you know a lot about that network, then you can reasonably use sizes that are appropriate for that network. And I think that's actually a pretty common case.
Brian Dixon, GoDaddy. Sorry, Warren, would you mind following up with what for those not following that other draft, or what exactly it's talking about? I think there's definitely useful recommendations. It might need some embellishment, and just this draft, I mean. And the recommendations might need to be split out on the recursive to auth versus client to recursive, as well as whether you know more about your immediate environment versus not in terms of the selection. But having a sensible default for implementations, I think, makes a lot more, is very valuable. And I think highlighting the specific general default of 1400 maybe to make it more readable and easy for somebody to look at it and say the actual recommendation up front saying 1400 and here's why.
Jeff Houston, yes, I am the author of that, but I was going to head down a subtly different direction. I think you're being too prescriptive, and I think you're jumping to a solution from a minority case. When you actually start looking at the survival mechanisms for large fragmented UDP responses, they're actually higher than most folk think. They're not 100%. There's nowhere near it. But the problem really is that resolvers tend to rely on timeout to detect failure. Because how do you know to go to TCP? You need a TC=1 response, which means the server has to go hunting. And we said on Flag Day, that's a really bad idea. So you're jumping straight to a solution. You should set the MTU for this, and that will solve all our problems. It won't. It's probably the wrong approach in general. Now, there was a piece of work that was looked at briefly and discarded, which was actually quite interesting. Davey Song came up with a thing called ATR, which sent back a big UDP response, including fragmentation, waited 10 milliseconds and sent back explicit truncation. It sent back the query with the trunk 8-bit set. If you lost the fragmented UDP, there was a packet saying try TCP immediately. It got rid of the timeout. Your problem in performance is actually the timeout. And what you want to avoid is two things. You want to avoid a lost TCP packet too big timeout as much as you want to avoid a UDP timeout. And so what you've really got to think about in the DNS is for UDP, you actually want to run with quite high MTUs, as high as you can, because when you go to TCP, when you finally get there, that's the last resort. And there you need to run with low MSSs. And you're kind of saying, well, I'm going to solve the UDP problem and that's the end of it. That's not true. There's a much deeper set of interactions. And the thing I think we have to realize is that if you want that switch to be fast, you actually have to encourage a TC=1 setting. One way is this muted flag day that says no large UDP forever. Now, like I said, that's kind of solving the 6 to 12% problem for everyone. So we're all part of the problem now, even though large UDP packets make it for a lot of folk. This is a minority case. And it's sort of imposing the worst possible solution, i.e. everyone goes small, simply because some folk don't make it on the lifeboat. So I actually think deeper problems here. Interior is looking at it right now. There is no hurry. Most of the time, most responses are quite small, except for .org, and that's their problem. We can wait for a while and think about this a bit more. I don't think this is ready for adoption.
Brian Dixon, GoDaddy. There's another use case not addressed or identified within this draft, which is the fragmentation considered harmful. That was published several years ago about the vulnerability to cache poisoning caused by fragmentation. I've done follow-on research on that. I haven't published it. If I think I've asked before if folks are interested in that, I think that would help justify one of two recommendations, either doing the smaller below MTU as far as like this draft is concerned, and the other of which is doing the DNS cookies. And one of those two would be adequate for addressing the cache poisoning attack caused by fragmentation. And I'm not sure, do we want to take that to the list?
Okay. What I think we're hearing here, I'm sorry, did you want to respond to, did you have a response, a reply to the comment? So it sounds like that should go to go ahead to the list. And sort of the larger point, what I think we're hearing here is that this does represent a significant amount of effort, and thank you. But there is related work going on in int area to the general problem, to the general issues around fragmentation. We should wait and see the status on that. We should take a look at what's going on there and figure out what of this work that is perhaps still useful as advice to DNS implementers and as DNS specific. So I think that what folks who are interested in this work need to do is review what's going on in int area and then further develop perhaps any aspect of this that is specific to DNS and the implementation of DNS. So that sounds like a reasonable way forward. And I see our Jabber scribe at the mic. Go ahead.
Yes, relaying for Chatlab. Suzanne, the int area work is done.
Okay. Then it should, well, for some value of done.
So Paul Hoffman. So I know that the one draft that Warren said is in RFC editor queue,
Okay.
but I thought there was other work that was sort of following along that in int area, or was that it?
All right, if it's
Did
in
that
RFC
fall
editor
away?
queue, that makes the task easier. of
Very good.
figuring out.
Okay, so
Right.
Warren said that it was just that one document.
Okay.
I'm sorry? Okay, he thinks that it. So I think we should check because I seem to remember that there was work that was going to happen in int area after that finished, at which point then we would wait to be beyond all of it. But if not, once something's in the RC editor queue, we can read it and then do the determination you just said of therefore what is left.
Okay. Warren, could you do the chairs a favor and send the pointer to that document to the list? And then you and the chairs can get together and make sure that we've pointed out all of the related work and proceed from there. Go ahead.
I have another comment from Mark Andrews. Cookie isn't perfect for defeating fragmentation. We'll know tsig key and then some draft name, draft Andrews DNS up. Defeat frag attack 00 can defeat the attack. So basically Mark wrote a draft on this as well.
So we'll review the work in int area, however much there is of that, and in whatever state, and we can further discuss on the list. Thank you very much.
So next up, Roy Arends.
Hi, everyone. Let me just put this a little bit higher. Perfect. My name is Roy Arends. I work for ICANN. All opinions expressed here are my own. The facts speak for themselves, but the opinions are not necessarily shared with my employer. I wanna say that beforehand before I start. The reason I say this is because this topic is a little bit controversial. So I would like you to keep an open mind, and I'm wearing my good shirt, so careful with the tomatoes. I'm going to talk about private space names. The problem is there are no private space names. There is no such thing. There's no document, no RFC that tells you how you can use private names in the DNS. I'm talking about something similar to X headers in MIME types. as RC 1918 address space, X subtag and private use language tags, etc., etc. Even in the DNS, we have private types, we have private R codes, we don't have private use names. So if you then look at the solution space, I mean, in absence of a standard document of how to do things, people think of their own way of doing things. For instance, advice that I sometimes hear, well, why don't you just register a name and do everything you want to do under that registered name? Well, that's not really private. That's not really internal. Another one I hear often is, don't do it. Well, that's not really helpful because people are going to do it anyway. Or pick something easy to remember, not used elsewhere. And I'll show you that in a minute, what happens then. We have a draft, the internal draft from Warren, also the alt draft from Warren. There is .local everywhere. .local stems from an old Microsoft TechNet article that had to be put through RC 6761 in order to protect it. And then, of course, we have home.arpa, which is also kind of a private use space. This is the result of looking at ITHI data. ITHI is the Identifier Technology Health Indicators by published by ICANN. And what you see here is a top 13 of domains that do not, top level domains that do not exist on the internet that people are querying for. They might exist in private spaces, but not in public spaces. So if you then think about what the solution should be, I think personally what would be useful is a simple and concise BCP. Something that says, if you want to do this, do it like this. And choose a label without a semantic meaning. And this is actually the core of my presentation. It does not need to have a semantic meaning. And preferably, it needs to be short. So what's the problem with the semantic meaning? Is because internal is not exactly the same as private, is not exactly the same as alt, local, home.arpa, or neighbor, or global, or whatever string you want to use. And all of these strings are too anglophonic. They don't work in different languages. Also, please use a use a label that is defined as never to collide. Right? You want to prevent collision with anything expected in the future. So initially I had a bullet point that says maybe a one-character ASCII domain. Well, that's never going to happen, I can tell you that. That will be a policy development hell, let alone all the things you need to test in order to get it working. So maybe you can use a two-character ASCII domain. Now, this is also a bit of controversial part because the two-character ASCII domains, they are governed by RC 1591. What does RC 1591 state? It says, IANA is not in the business of deciding what is and what is not a country. The two-character codes are country code domains. Right? IANA is not in the business of deciding what is and what is not a country, and so it leaves it to the ISO 3166 list. Now, between you and I, ISO 3166 is also not in the business of deciding what is a country code or not. What they do is they map official country names to two-letter codes. And I'll show you that list. This is it. There are 676, or 26 squared. And they have colors. No, what I mean is they fall into categories. I'll start with a simple one. The white background, those are codes that can be assigned. They haven't been assigned yet, but they can be in the future. So that's a no-go. We can't use any of those. The green ones are those that have been assigned, like BE for Belgium or DE for Germany. Then we have the yellow ones. The yellow ones, they are exceptionally reserved. Those are actually quite interesting. UK, for instance, is exceptionally reserved. UK in the context of ISO 3166 does not mean the United Kingdom. UK in the context of 3166 has been exceptionally reserved for to make sure it doesn't get allocated for any other country. So the official code for the United Kingdom and Great Britain and Northern Ireland is GB. And why is that? Because if you are going to get acronyms or not acronyms, initials for the first two words or the first one word of a country, you quickly run out of united, of republics, of kingdoms. You quickly run out of URs and Ks. So that's why they decided to take the first string that's uniquely identifying the country. In this case, Great Britain. Sorry for the detour. EU is another one that's reserved. And you know what? EU is not a country at all. Well, you know that, right? But what I mean, in the context of ISO 3166, EU is not considered a region. And I'll get to that in a minute, why that is. I'm not talking about the top level domains. I'm talking about the context of ISO 3166. So I want to talk about these. These are the user-assigned codes. There are 42 of them. AA and ZZ on the top left and the bottom right. And then QM to QZ, XA to XZ. Now, what does the ISO 3166 standard say about this range? You can just do a grep on the user sign, and then you get these three things. Construction of the Alpha 2 code. How is it done? How is it used? How are these two codes used? It says here, the ISO 3166 standard uses combinations in the range of AB to QL, RA to WZ, and YA to ZY. That is what the standard uses. Those are available to the ISO 3166 maintenance agency. In addition, 42 Alpha 2 code elements are not used in ISO 3166. So they are not used in ISO 3166. And in the context of 3166 means they will never be assigned, they will never be reserved. And they go on to explain why. Special provisions. Users sometimes need to extend or alter the use of country code elements for special purposes. And it then gives some guidance. The guidance, for instance, if you need a code element to represent country names not included in this part of ISO 3166, these 42 are available. Now, I know it says country names here, but keep in mind this is guidance. So, how are these codes used elsewhere? And let's start with the ISO codes. ISO standards. 3901. That's the recording code equivalent to ISBN. It reserves ZZ for direct registrants, independent of any country. Now, the interesting one here is 4217. That's currency codes, like, let's say, Singapore dollar, SGD, right? That's an official currency code. The SG in SGD comes from ISO 3166. Swiss franc, CHF. The CH come from ISO 3166. GBP, remember, not UK, but GB. GBP, the GB comes from ISO 3166. So how are they using these user ranges? If you want to pay in gold, because you can pay someone in gold, and it's a transaction that includes gold, right? You use the code XAU. If you want to pay in silver, it's XAG. Now, you can think twice what AG and AU stand for, but if you want to pay in Bitcoin, this is true. If you want to pay in Bitcoin, you can use XBT. I think that's pretty cute. But the XA then refers to the 3166 code, because it always refers back to the 3166 code for the first two characters. So now I can tell you why EU is actually in the ISO 3166 list. Remember, it's not a country and is exceptionally reserved. It doesn't map to any official name. The reason it's in there is the euro was introduced in 99. And when the euro was introduced in 99, and you refer back to ISO 3166, there isn't anything there for EU. Now, of course, you might have a risk in the future that EU will actually be assigned to an official country, right, that may have, I don't know, rupee or ruble, and then you have EUR. So that's a collision, so that's why in ISO 3166, this is exceptionally reserved. That's where EU stems from. There are a lot more. I quickly skip over them. International Civil Aviation Organization, ZZ for UN travel documents. The IATA have those codes. XK for Kosovo, you see that a lot. WIPO, World Intellectual Property Organization, they use these codes all over the place. UN Low Code used a lot, in a lot of organizations using them. Reserves XZ for international waters. A few more, but XZ is for international waters. I think that kind of stands out. It's not a country. World Bank, XC for the Euro area, XU for North America. Interpol uses that. When Interpol sends a document out to all of its agencies worldwide, it can basically say, oh, this is from this country, because Interpol is not on the country level. It's an international organization. So when they send a document, they say ZZ to all. ZZ being from that ISO 3166 list. A little bit closer to home, the CAP form, right? The Certificate Authority and Browser form. They use XX to signify a country that's not covered by ISO 3166. Unicode uses these things a lot. RC 5646. These are the tags for identifying languages. You can have your own user code in there, your own user assigned code in there. And as an example, here's Kosovo again. There's SQ-XK, that's for the Albanian language in Kosovo. Or SR Cyrill XK, that's the Serbian language in Cyrillic script in Kosovo. I mean, these are currently on your laptops, right? In some library somewhere. And even closer to home, and I think this one is pretty cute. Remember XN-? That's the, I think it's the, what you call it, ACE, the ACE prefix. How is that chosen? Why not PP-? Why not LL-? And it turns out that the the IANA had in 2003 a little protocol for that. It's published, the link is under that list. It's a little bit obscure to find, but it's there. It says the following steps will be used to select the 2-character code. And here is that ISO 3166 mesh again. They're actually using 18 of the 42 codes. But it literally says here, and I think this is important to mention, the use of ISO 3166-1 user-assigned elements removes the possibility that a code will duplicate a present or future CCTLD code. So I'm trying to build a case here that it's actually safe to use these codes. These codes are used as intended in various standards, not just RFCs, but also ISO standards itself uses these. So we also know that these will then never be assigned or reserved by the ISO. If they would do so, then all of these standards that uses these private code need to be changed. So it's highly unlikely that that will happen. We also know that because of that, these codes may never be delegated as country codes, right? Because IANA follows RC 1591. We also then know that these UA codes are collision-free because they will never be delegated. And lastly, one important point, the UA codes, user-assigned codes, they have no semantic meaning. Great, that's 5 out of 5. So, in fact, you can have different code for different uses. Remember, you have 42 codes. I'm not suggesting you just do whatever you like. You're going to get that same mess again. There needs some procedure around it. But I had a conversation with a colleague the other night, and this person basically said, if this was done 10 years ago, then maybe, as an example, we could have ZZ for private use names, or XH for HomeNet names, or XM for MDNS names. Now, I kind of put this quickly under here. It's just an example. I'm not suggesting we should use it that way, but if we've known this 10 years ago, this would have been a possibility. So then there's the question if this should be delegated or not. Now, personally, I think it shouldn't be. If you don't delegate it, then a validator behind a resolver will validate that these things do not exist. That will negate any inserted private space data. And so a validating stub resolver now needs a negative trust anchor for these to work. So that's a whole lot of configuration. So on the other side, if it's delegated as an unsigned delegation, you avoid configuring each individual stub validator with a negative trust anchor. Plus, on the negative side, you basically allow anyone in the world to insert this private data in your device. Right? Keep in mind, you've done everything you can on a stub resolver, right? On a stub validator. It's secure as possible. Your SSH is on the latest version. Your certificates have been carefully selected, etc., etc. And now, without your knowledge, people can insert private space data. So a way around that is to actually have a positive trust anchor for a signed private space top-level domain. But anyway, that's going to be an interesting discussion, I'm sure. So just to paint the bike shed a little bit, I'm going to suggest ZZ for private use names. It can be any of these 42, but I thought ZZ was the cutest. We had at home a little little contest, and I just had some names ending with ZZ, and they stood out the best. But this is not set in stone. It's just a suggestion here. What are my next steps? Now, I'm sure this is going to be very controversial here, and I'm sure a lot of people are going to say a lot of things about this. So if this takes too long and we run out of time quickly, I'm not sure how much time we have. 0. Quick. Okay.
We can give you a couple of minutes for
All right.
questions, comments.
I'll finish this one up. This is my last slide. So let's move the discussion, if it takes too long, to the mailing list. If, but only if, there is sufficient interest, then hopefully by the next IETF, I can ask the working group chairs, because that's the process. I'll ask the working group chairs to see if there's enough consensus to adopt this as a working group item. And if that's the case, if it's adopted as a working group item, then the real work starts. We need to engage early with the IESG, the IAB, IANA, and ICANN communities to make sure we develop a path of least surprise. Thank you. And keep in mind I have my clean shirt on.
Brian Dixon, GoDaddy. This is great. I'm highly in favor of this. I have a use case that would specifically fit very, very well into the delegated unsigned for dealing with some of the implementation issues in architecting a locally scoped, globally unique naming for doing the DNS trace route and naming of unnamed and unaddressed, not addressed globally and not named globally. Anyway, I'm definitely interested in this and would be willing to review and maybe even contribute if necessary. Also, I think it's interesting to point out that the apex of this would be ZZ Top.
Well, thank you for your support. Warren.
So Warren Kamari, Google. I've got lots of thoughts of this. I'll try and keep them short. So I definitely understand.
I'm half deaf, so there's something in the back here. So
I'll try to talk better.
Yes.
So I mean, I definitely understand and agree that we need some sort of internal namespace, a way to carve off a set of namespace. Enough that back in 2017, I wrote a document suggesting we do something like this, and I called it .internal. Yeah. I brought along to Dnsop, and Dnsop largely stood up and said, sounds like a fine, or at least this is my recollection, sounds like a fine idea, don't do it here. This is not a special use domain name. It does not require special use handling. This should go to ICANN. And so I took it to ICANN. It hasn't really progressed there yet. But, the last time this came up, Dnsop said, sounds interesting, not here. The name,
can I respond to that?
Sure.
All right. Otherwise, I need to remember all the points. Sorry. I'm very well aware of the .internal document, and I'm in favor of having something private spacey. There's a fundamental difference, right? And that's what I'm trying to make clear. Is the fundamental difference is the semantic meaning in the very long internal. Plus, the other thing is, I think the document requires currently to have it delegated, and I'm not. This is slightly different. But go ahead. Next point.
Yeah. On the specific string, I think that a semantically meaningful string is sadly important. It doesn't really matter what the semantic string is, maybe actually having a couple. But the reason that people have chosen whatever names they have chosen is because they want it to be somewhat descriptive. Okay, I think that that's a place where we're going to disagree.
Yeah.
If people would use, the reason people have used blah, blah, blah .corp is because they wanted to describe something. Blah, blah, blah .zz, I think it's just going to be confusing to the average user. I also think that this does require some sort of delegation, and it needs to be an insecure delegation. We can have a longer discussion on the mailing list about why. Basically, I want something to go forward. Last time I heard not here. I'm fine with it here. I just want it to go somewhere. I'd also encourage people to please read Suzanne's document on 67 STW. I can't remember the actual name. Yeah, it's been posted on the list a few times. It's expired, is why really it helpful
it needs revision.
All right. I want to respond to that.
Yeah. So first I want to close the line. Okay. Having said that.
All right. I'll
Yeah, we
keep it
kind of
short.
need to keep moving, but also I would like to clarify up front that at least I believe as far as the chairs are concerned, the IETF does not have the ability to declare what will or will not go into the root zone, and any further discussion of this document and its purpose in the IETF has to take into account the fact that the IETF does not decide what goes into or does not go into the root zone. So that division of I think what is hung us up before on the point that Warren just made about where do you talk and where do you do these things. I think Roy makes a very important point on his last slide about coordination among the assorted activities and bodies, and the important dividing line is that the IETF does not decide what goes into the root zone or not.
I'm acutely aware of that. Thank you for making that clear.
We are a bit time limited, so if you can keep your questions short, and mainly speak out support, non-support, and we have one remote. Okay, yeah, thank you. Yeah, Stuart, and then Jim, and then we go further with Terry. Yeah.
Stuart Cheshire from Apple. I'll talk fast because I know we're short of time. Firstly, I think this is an inspired idea. I wish we'd thought of this 10, 15 years ago. As Suzanne says, IETF doesn't control what ICANN puts in the root zone. That's true. ICANN has made decisions about what goes in the root zone, specifically following ISO 3166, which means that these two-letter codes will never go in the root zone. Now, if we can have a discussion with ICANN and clarify that that really is the position ICANN holds, then that creates some two-letter codes that we know will not cause a conflict. And that is a wonderful observation. And would have avoided an awful lot of fighting. So first, let me thank you for that. One quick terminology suggestion: where you talk about private DNS, there's a lot of talk here at IETF about DNS privacy, DNS over TLS, DNS over HTTPS. The term private DNS has kind of got overloaded to mean that. So I would say internal DNS for what you're talking about, where a school or university or company has an internal name server. I try to call that internal DNS to distinguish it from private DNS. So that's just a terminology thing to avoid confusion moving forwards. And then the final comment I'll make is it's tempting when you think about declaring something for internal use, like RFC 1918 addresses, that you say, you are free to do whatever you want with this. But the you in that sentence is not defined. There's the vendor of the operating system, the vendor of the application, the person who purchased the phone, the person who runs the network it's running on, and all those yous may have different opinions, which was at least the intention in RFC 6761 was those 7 questions were not supposed to be the rules, but they were supposed to be a framework for which of these different communities of people may need to know something about this in order to handle it. And bringing it back to the example you made with currencies. ISO 3166 says these codes are unused, so individual groups can use them for private use like currencies. That's not the same as saying that every individual can make up their own currency codes and I can go to the bank and make a deposit in ZZQ. So it's not that anybody can do what they want. It is that the banking industry is free to define their own standards for what those codes means. And the analog here, I would say, is that the IETF has the responsibility for giving meaning to those values, not to say that it's a free-for-all. And because saying do what you want, and I'll give one final example of this draft I've been working on with Warren, IPv4only.ARPA. If you send that over your DNS over TLS connection to Quad 8, it doesn't know your local network's NAT64 prefix. So in order for that to work, the software has to know to treat it specially. And similar things apply here, that saying do what you like doesn't work when the different people writing software have different opinions about what they'd like.
Thank you.
Jim Reed, RTFM. Roy, very provocative.
I think we're going to run into lots of the problems we had with the earlier discussion around .alt and .internal and all the rest of it, and potentially we'll have even more problems if and when this gets in front of ICANN, and we're trying to have some discussion around whether some names should go on some kind of magic list of names which are set aside but not allocated or not delegated, or having a process for that. I think the whole thing could get very, very horrible very, very quickly. And we could also, in the same situation, things can get very, very horrible very, very quickly about whether this name should or shouldn't be delegated, whether it should or shouldn't be signed. And I think all of those problems will just come back and recur over and over again. If this is to go forward, I think the simplest thing to do would be to say, these are some country codes, and perhaps not even list them and say, there is a set of codes in the ISO 3166 list which are set aside for sort of private use. If you want to use a private use label for DNS purposes, go to that list and pick one. And then you face the consequences of that yourself. If you want to sign it, you figure out how to do trust anchor for it. Yeah. If you're then going to plug your network into somebody else's network, there's a chance that both of those networks are using the same internal private use label, in which case, tough. I think something like that is probably the best we can do, but trying to come up with, say, an informational document or even worse, a standards track document in this area, I think is ultimately going to have the same problems we had before, and we'll get no further forward. I think also make a reference and say to the 3166 thing, don't list the country codes in an RFC document, because the 3166 list isn't necessarily fixed. That may change at some point in the future for reasons that we can't possibly comprehend or anticipate.
Thanks, Jim.
We're going to go to our remote. John, if you can go ahead.
I don't know.
We appear to have lost our remote.
Yeah. Okay.
All right.
Maybe, yeah. Okay, Terry.
I'll go. So Terry Manderson, and God, I have no idea what hat to wear on this. So let's say no hats. As the person in the hot seat around the .home skirmish, I really like this. This is avoids, and when you introduced this, you said this might be a sensitive political topic. I actually think this is really good because it actually avoids political skirmishes. I think this is great. It is pragmatic thinking. It is inherently pragmatic, and I love it. It is sensible. It makes sense to me. So I'm happy to read, review, contribute text as necessary. Thank you.
Thank you. Thanks, Terry.
Wes Hardiker, ISI. In order to make sure that everybody hates me, I'd like you to actually do both, one unsigned delegation and one non-delegation.
May I suggest something? I'm happy for this document to be undelegated, and then we can have the internal document that basically says delegated, and we have two approaches to the problem: one delegated, one undelegated.
Undelegated will take significantly less effort.
All right.
Okay, first comment from Peter Spacek. It's not correct to claim that there's no risk of collision. Collisions will happen when two organizations using .zz are being merged with each other, similar to RFC 1918. Main value of this document is documenting what terrible things will happen if you use .zz for long enough.
I want to respond to that.
And a second comment from Cleansing. I don't know. This presentation is somewhat misrepresenting RFC 1591 and the reasoning behind it and the context and background of 3166, including the status of the reservation space, including the meaning of never. Not worth taking up working group time, but the authors are welcome to discuss with me offline in either of my capacity as major contributor to 1591 or liaison to ISO/TC46. And also, it also misunderstands the relationship between what ISO 3166/MA can do and what ISO/TC46 can do. Reserved has a funny meaning here.
All right. I want to respond to that. First of all, if there's two organizations that both use ZZ, there are probably two organizations that have an HR department, two organizations that have a financial department. They will merge and they will figure this out. I think when they do that, a internal top-level domain like ZZ is the least of their problems. So, sorry to be blunt, but I don't think that's a real problem. And the whole idea is that these are locally unique, but globally not unique. That's the whole point. It's the same way with RFC 1918 address space. If you use it in one organization and in the other organization, you merge the organizations, you have that problem. But thank you for your comment. John Clanson, thank you for your response. Looking forward to engage with you off list, but would welcome very much your engagement on the working group list as well. Thank you.
Hi, Sanjeev Gupta. First, thank you for a very well-written, readable draft. It clarifies lots of issues and covers the background. My concern is actually since enterprise users have shown an unwillingness to use .local, and as you have shown, there's a lot of fragmentation, .home, .private. Who would actually use this? Since most enterprise administrators I know, and I come from an end-user organization, don't read, don't care. And further, Microsoft's, which is the largest deployed enterprise software, Microsoft's own guidance on whether to use .local or not to use .local has flip-flopped over the years.
Yeah.
So who would actually... I'm not going to the merits of this proposal. I'm just wondering, would anybody actually read it and implement it or care about it?
Well, first off, the reason that people use different things now is because there's never been a standard that explains how to use this. There's never been a best current practice that says how to use this. Now, the only thing that we can do going forward, if there is such a document, is point a listening ear to this new document, and we will see what the future brings. But at least when people make their own things and basically say there is no other thing, now we would have, in the future, we would have this document. So that would be my point. I don't think there's any value in trying to force people to move over. I think that's impossible. It's not necessary. Eventually, using this, you kind of have some guarantees about less collisions. For instance, .corp, for instance, .home. We all know that these have a few collisions. In the ICANN ICANN new GTLD space, there are a couple of organizations that have applied for these. A lot of companies have these locally configured, and these will bring issues, and you want to do the collision avoidance. Hence, a document for this will be very helpful, I think.
So I ran up to the microphone because I wanted to have a go at answering that question.
Right.
As things evolve in DNS, like DNS over TLS, Android provides a setting that you can turn on strict DNS over TLS. And if the user enters Quad 8 as their DNS server, and you look up your company mail server, mail.internal, you fail because Quad 8 doesn't know your internal address of your internal mail server. If we have an RFC that says names ending in .zz, do not go over your TLS public resolver. They have to go to the resolver that you learned via DHCP or IPv6 router advertisement. Then your mail server does work. So the incentive for corporations to use these names is because these names work, and picking a random thing and sending it to Quad 8 doesn't work. So they'll find out pretty quickly the benefit of using something that has a document that defines how it works.
Okay. Thanks, everyone, for your comments.
Yeah, thank you very much for the comments. Please, yeah, we're done. Now, please continue the discussion on the mailing list. I think we had a very good discussions. The chairs very naively only reserved 15 minutes for this. Stupid. But apologies to Tim. So Tim Wattenberg, his presentation drops. But
Paul made a funny comment who said my timeout draft timed out. So I guess that's
yeah. So as a courtesy, we would like to ask you, everybody, read Tim's draft, Tim and Tom's draft, and give comment on the mailing list. It has value. Please, okay, thank you. We're done. Yeah, final comments.
Thanks very much, everybody. I think we got some good work done here in, where the heck are we? Singapore. And we will see you on the mailing list and in Vancouver. Thanks very much.